Hello everyone. In the last video, I discussed about the force acting on a charge moving on a magnetic field. So when a charge moves on a magnetic field, the force acting on that charge is given by F is equal to Q into V cross B, where V is a velocity, B is a magnetic field, the magnitude of magnetic field. So F is equal to Q into V cross B. So now the force is maximum when the charge is moving with a velocity perpendicular to that of magnetic field. So when it is perpendicular, we also use here a small function of mathematics, that is about vectors. You know that A cross B is equal to AB sine theta. So force will be equal to Q VB sine theta. So the force is maximum when the angle between the velocity and magnetic field is perpendicular. They are moving at 90 degree. So now F is equal to QVB and theta is equal to 90 degrees, sine 90 is equal to 1. So F is equal to QVB. So this is an expression for force on acting on a charge or moving only on a magnetic field. Now, let us define what is magnetic field and let us also discuss its SI unit. So, what will be B? B will be equal to F divided by QV. Okay. So, now let me consider 1 coulomb of charges, or a unit positive charge of magnitude 1 coulomb moving with a velocity. Okay, Q is equal to 1 coulomb moving with a velocity V is equal to 1 meter per second. So, then B is equal to F by 1, that is B is equal to F. So the magnitude of magnetic field is a force acting when 1 coulomb of charge is moving with a velocity 1 meter per second. SI unit of magnetic field is said to be 1 Tesla when 1 coulomb of a unit positive charge is moving in a magnetic field, with a velocity of 1 meter per second. Then the force acting on it will be 1 Newton. So if magnetic field is said to be 1 Tesla when B is equal to, you know this formula, B is equal to F by QV. So when 1 Newton of force is acting on a charge of 1 coulomb, okay, which also moves with a velocity of 1 meter per second plus 1 meter per second. So magnetic field is said to be 1 Tesla. So this is the SI unit of magnet. The expression for force moving on both magnetic field as well as electric field is given by F is equal to Q into E plus Q into V cross B. So this is a force acting on a charge moving in both electric field as well as magnetic field. You know this expression. This expression you have already studied in the first chapter. The relation between force and electric field. So this force is defined by Coulomb's electrostatic force, and how electric field is associated related with the force. This is a relation between force and electric field. And in the previous video I have told you that force acting on a charge moving only in electric field. Now a charge is moving where it has both electric field as well as magnetic field. So this is the expression for force moving in both electric field and magnetic field. So in general I can write take Q common, F is equal to Q into E plus V cross B. So this is the expression for force acting on a charge moving in both electric field as well as magnetic field, and this force we call as Lorentz force. This force we call as Lorentz force. Thank you.